Hello everyone, I'm going to take a look at two more trig identities. So, first one, tangent plus the secant times 1 minus the sine, and that's equal to cosine. So remember, a couple of our methods that we can use. One good starting point is that you probably want to work with the more complicated side first. In this case, that's definitely the left-hand side. Another option we have is to rewrite everything in terms of sine and cosine. That can help us with simplifying, canceling things out. And then we also want to remember our Pythagorean identities, which can help out as well. In this example, we have two binomials that are being multiplied here. So let's multiply this all out first. So distributing the tangent. So we have the tangent times 1. And then minus the tangent of x times the sine of x. And then let's distribute the secant. So then the secant times 1, and then secant of x times negative sine. And then my right-hand side, that's going to stay the same throughout this entire thing. Okay, no like terms that we can combine together yet. We have some tangents, we have some secants, we have some sines. Let's rewrite everything in terms of sine and cosine. So let's see, the tangent, that is sine over cosine. And then here we have a sine of x. And then plus secant is 1 over cosine. Alright, I have two fractions here where we have some multiplication. So why don't we take care of that right away? So we have the sine of x over cosine. This came from our tangent. And then doing our multiplication here, remember this is like it's over 1. So sine times sine, we have sine squared of x. And that's over cosine. And then 1 over cosine. And then in our last fraction, again, this is like it's over 1, so just 1 times sine in the numerator, sine of x over cosine of x. So that works out nice because now all of these fractions, we already have that common denominator. So all these fractions, the denominator is cosine. So we can combine all the numerators together. We have sine of x minus sine squared. And then plus 1, and then minus the sine. And that is all over the cosine of x. And the right-hand side still staying the same. So let's see if we have any like terms here. So sine of x minus the sine of x, so that will be 0, so those cancel out. And we're left with negative sine squared of x plus 1. I'm going to flip that, and I'm going to write that as 1 minus the sine squared of x. Hopefully the numerator, that looks familiar to you. That is one of our Pythagorean identities. Sine squared plus cosine squared is equal to 1. So that means 1 minus the sine squared, that's the same as cosine squared. So substituting that numerator, that's the cosine squared of x over the cosine. We have two cosines in the numerator, 1 in the denominator, so one of those will simplify. And we are left with just the cosine of x. So the right-hand side stayed the same all the way through. We didn't do anything with that. We multiplied everything out, rewrote in sine and cosine. And then we got some nice simplifying. And then the big step here, our Pythagorean identity, able to replace 1 minus the sine squared with cosine squared. But then we end up with what we're looking for. Okay, And last example, this one we have secant squared of theta, sine squared of theta, and that's equal to secant to the fourth of theta minus, in parentheses, tangent to the fourth of theta plus the secant squared of theta. In this example, this one is going to be a little bit different than the ones we've done, but I'm going to start off with the more complicated side as usual. So I'm going to start with the right-hand side. Now, I have some things to the fourth and I have some things squared here. I want to group these two terms together because they both have to the fourth power. So I need to distribute that negative sign. So just to start with here, my left-hand side is going to stay the same. And then distributing that negative, that's minus tangent and then minus secant. Then I wanted to group these two terms together. The reason I wanted to group those together is because they're both to the fourth power, but this is still the difference of perfect squares. This is secant squared squared, and this is tangent squared squared. So we can actually factor this. So the shortcut, factoring the difference of perfect squares, it's going to be 1 plus and 1 minus. So secant squared plus tangent squared, and then secant squared minus tangent squared. Alright, so now we have tangent and secant squareds here. One of these is the Pythagorean identity. So our Pythagorean identity, tangent squared plus 1 is the same as secant. So that means that the secant minus the tangent, this piece, this is equal to 1. So that simplifies. Here we have the secant squared plus tangent squared, and then that's just equal to 1. So we don't necessarily even have to write that, but just putting that step in to show you what's going on. And now our parentheses, because we're multiplying by 1, we don't need those. So then we have the secant squared plus the tangent squared minus the secant squared. So now we have some like terms we can combine. We have a positive secant, a negative secant squared. So these will simplify to 0. And we are left with the secant squared of theta, the sine squared of theta, and that's equal to the tangent squared of theta. So now this is where this problem gets a little bit different. So when I get to this point, I only have the tangent squared to work with. So it may be not quite obvious as how we can turn this into the secant squared minus the sine, or times the sine squared. So instead what I'm going to do here is I'm actually going to jump over to this left-hand side, and then I'm going to work with this for a second. And I'm going to do that down below here, just a little bit of scratch work. So secant squared, sine squared. I want to work with this a little bit just to see what happens. Secant, that's the same as 1 over cosine. And then we have sine squared. I can multiply these together. We get sine squared over cosine squared. And sine over cosine, that is the same as the tangent squared. So that's what we want to end up with here. So we want to end up with this, but we can see that this ends up matching. So then what I'm going to do is I'm just going to use these steps, but I'm going to go backwards to get to where I want to go. So then the secant squared, so I'm keeping this the same, so I can still use my identity, my justification. But now I'm going to use these steps, my scratch work. I'm going to use those steps going backwards so I can end up matching with what I want. So tangent, that's the same as sine over cosine. And then we'll split that up. So that's 1 over cosine times the sine. And now we can rewrite 1 over cosine as our secant squared. So this left-hand side was able to stay the same the entire way through. Secant squared, sine squared. So the left-hand side stays the same all the way through, but we reach this point where not quite obvious what to do next. So we actually jumped over to that left-hand side, and we worked with that a little bit to give us some guidance as to what our next step should be. And then to finish this up, we just used these steps going backwards to end up where we wanted.